Myself, Prashant Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. So, in our last class of power electronics and drives, we were discussing the monostable multivibrator circuit using 555 IC timer and its application. So we have so far discussed about its application as a frequency divider, as a pulse width modulator circuit, or as a say linear ramp generator circuit. So today we'll discuss another application of monostable multivibrator circuit using 555 IC timer circuit as switching the relay on. So monostable multivibrator can be used to drive a relay. This is the circuit shown here. So see, this is the circuit. This is the relay to external device. This is trigger. This is for threshold. This is the timing circuit. This is for control input voltage. This is supply, and this is output. So this is going to the relay, which is connected to the external device. So this circuit is called time delay relays. Actually, in this circuit, the relay will stay on for a certain period of time once activated, and this time for which the relay is on can be anywhere between 0 to 20 seconds, depending on the various values of R and C in the timing circuit. So if you change this value R and C, or only R, so keeping C constant, you can change the this timing period for which the relay can be made on. Okay, so let us take an example. If the relay is to be on for a period of 10 seconds in order to energize an external device, then value of the resistor and the capacitor can be calculated by using this. So T equal to, as we have already calculated this, the T equal to approximately equal to 1.1 into R into C. Now let us suppose the value of the C is 10 microfarad. Then for putting this T equal to 10, that is 10 for 10 seconds we have to keep the relay on. So put T equal to 10 and C equal to 10 microfarad, then what will be the value of the R? So if you calculate a put here, it will be calculated as approximately 909 kilo. So to get this 909 kilo, you can use a potentiometer which can be adjust the resistance and therefore adjust the time delay. Okay, so in this way this IC 555 multivibrator circuit can be used as say switching the relay on, particularly time delay relay. So that is another example. So another example we will discuss, that is the example of missing pulse detector. See, a circuit of a missing pulse detector is shown here. Okay, so this is the missing pulse detector circuit. A PNP transistor is connected across the capacitor, and the input trigger pulse trend is given to the base terminal of the transistor, as well as the pin 2 to trigger input of the IC 555. See, this is given to trend pulse trends. It is given to the base of these transistors, and simultaneously it is given to the trigger input of the train of circuit too. The train of trigger pulses will continuously reset the timing cycle. Hence the output is always high, and if any trigger pulse is missing, the device detects this missing pulse, and the output goes low. Okay, so the detailed working is like this. When the input is 0, the PNP transistor is turned on. This is turn actually turn on, and the voltage across the capacitor, it is given as a 1 microfarad capacitor, it is used here, is clamped to 0.7 volt, and the output is high. When the input trigger pulse is high, this input trigger pulse is high, the transistor is cut off, and the capacitor will start charging. Okay, so if the input trigger signals goes low, again before the completion of the timing cycle, the voltage across the capacitor falls to 0.7 volt before reaching the threshold voltage. That is here, so that is of 2/3 of supply voltage VCC, and the output continues to remain high. Okay, so if the input trigger signal doesn't go low before the completion of the timing cycle due to missing pulse, so it allows the capacitor to charge to the threshold voltage, and the output will become low. Okay, so in order to make this circuit work as a missing pulse detector, the time period of the input trigger signal should be slightly lesser than the timing interval. So because of this, the continuous negative going input pulses will not allow the capacitor to charge till the threshold voltage, and the output continues to stay high. So in case of change of input frequency or a missing pulse, the capacitor will charge to the threshold voltage, and output falls low, and the waveforms of the input pulse voltage on the capacitors and the output signal will be like this. This is the trigger pulse, this is the capacitor charge, okay, maximum 2/3 of pieces, and this is output here. So so in this way this actually monostable multivibrator using 555 timer circuit can be used as a missing pulse detector. So once again I am repeating this discussion to use the monostable multivibrator circuit using 555 timer as a missing pulse detector. So PNP transistors is connected across the capacitors, and the input trigger pulse train is given to the base terminal of the transistor, as well as the pin 2 of that is the trigger input of the 555 timer. Here it is shown. So this is connected across this capacitors, and the trigger pulse train is given to the base of these transistors, and it is simultaneously given to the trigger input of the timer at pin 2. The train of trigger pulses will continuously reset this timing cycle, and hence the output is always high. And if any trigger pulse is missing, the device detects the missing pulse, and the output goes low. And the detailed working is like this. When input is 0, the PNP transistor is turned on, and the voltage across the capacitor is clamped to 0.7 volt, and the output is high. Now when the input trigger voltage is high, the transistor is cut off, and the capacitor will start charging. So if the input trigger signal goes low, again before the completion of the timing cycle, the voltage across the capacitor falls to 0.7 volt before reaching the threshold voltage, which is nothing but 2/3 of the supply voltage VCC, and output continues to remain high. And now if the input trigger signal doesn't go low before the completion of the timing cycle due to a missing pulse. So it allows the capacitor to charge to the threshold voltage, and output will become low. So in order to make this circuit as a missing pulse detector, the time period of the input trigger signal should be slightly lesser than the timing interval, and because of this, the continuous negative going input pulses will not allow the capacitor to charge till the threshold voltage, and the output continues to stay high. So in case of change of input frequency or a missing pulse, the capacitor will charge to the threshold voltage, and output falls low. And the waveforms of the input pulse, voltage on the capacitor, and the output signal is shown here like this. This is the trigger pulse trend. This is the capacitor charging voltage from 0.7 to 2/3 volt VCC, and this is the output. Okay, so with this we can say complete our discussions of monostable multivibrator using 555 timer circuit. So first of all, we have discussed the monostable multivibrator circuit using 555 IC, its circuit diagram. Then it's we have talked about its operations and its say waveform, and after that we have discussed the applications of monostable multivibrator circuit as a different application purpose. First, we have used monostable multivibrator circuit as a frequency divider. Then we have discussed monostable multivibrator circuit as a pulse width modulation circuit. Then we have discussed as a its use as a linear ramp generators, and then again we have discussed this as a switching the relay on, that is time delay relay for use in for any external device to turn it on after certain time period. Say it may be from 10 seconds or 20 seconds, and it depends on the value of the R. As we know, the time t equal to 1.1 into RC. If we take a certain value of C, and then for R we can use a potentiometer, we can change this time delay timing. And then we have discussed the monostable multivibrator circuit, its application as a missing pulse detector circuit. For that, we have modified this multivibrator circuit by using say transistors across the capacitors, and then use the trigger pulse of train of trigger pulses, which is simultaneously applied at the base of the transistors as well as the trigger input of the say timer circuit. And then by controlling this pulse train, we can in such a way so that the it is used as say in this from this waveform it can be found that if any a pulse is missing or any it can be detected. So this is the way we can use the monostable multivibrator circuit as a missing pulse detector circuit. So with this we will complete our discussions and on monostable multivibrator circuit using 555 IC timers. Next we'll discuss the use of 555 IC timer circuit as a bistable multivibrator circuit, and Now we'll discuss the bistable multivibrator circuit using triple pipe timer. So far we have discussed astable, monostable, and multivibrator circuit using triple pipe timer, and of course we have discussed their applications also. And as we know, say astable multivibrator has no stable state. Monostable multivibrator has only single stable state, and bistable, as its name suggests, it says two absolute stable states, and it has, since it has two stable states, that is high and low, so there it is called bistable, and it stays in that stable state until and unless an external trigger input is applied. So in this discussions we'll talk about this its bistable circuit using multivibrator circuit using triple pipe timer, and its bistable multivibrator circuit to be used as a flip-flop and memory cell. Let us start. Generally, it is bistable multivibrator circuit stays in the low state until trigger signal is applied, and it stays high until a reset signal is applied. So bistable multivibrators are also called flip-flops or latches. This is actually term flip-flop is generated because it flips to one state and stays there until a trigger is applied, and once the trigger is applied, it flops back to the original state, and that's why it is called a flip-flop. Now we will discuss the bistable multivibrator circuit using a triple pipe timer. So this is the circuit. So here we are seeing that the capacitor of the RC network is being not used because we don't require it, because RC charging unit is not responsible for generation of the output, and the generation of the high and low output is not dependent on the charging and discharging of the capacitor in the RC unit, but rather it is controlled by the external trigger and reset signal. Okay. So the circuit is can be explained in this way. Trigger and reset pins, that is pin 2 and 4 respectively, are connected to the supply to two resistors R1 and R2. Here it is shown. This is pin 2 and this is connected to this supply VCC, and so that they are always high, and in all the earlier cases, that is in astable or monostable cases, we have seen the reset pin is not used, and in order to avoid any accidental reset, it is simply connected to VCC. Here also it is connected, not connected, it is connected through resistors RC, so R2 actually, so that is not used in case of astable and monostable multivibrator circuit using triple pipe timer. So actually the reset pin is not used, and in order to actually avoid accidental reset, it is simply connected to VCC, but in this case it is not. Two switches are connected between these pins, that is and pins and the ground, in order to make them go low momentarily. So the switches at the trigger input will act as S set and S input, and for the internal flip-flop, and the switches at the reset input will act as a reset for the internal flip-flop. So this is shown. So this is for set, and this is for reset. Okay. So when the switch S1 is pressed, the voltage from VCC will bypass the trigger terminal and is sorted to the ground to the register R1. It is on. See, when it is pressed, so this will be sorted to the to register R1 to the ground, and this trigger input will be bypassed. So hence the trigger pulse will momentarily go low, and the output of the timer at pin 3 will become high. Okay, the output always remain high unless and until say no input from the threshold pin, that is pin 6 left, which is left open, better if it is connected to ground, and the output of the internal comparator, that is comparator 1, will not go high. When switch S2 is pressed, the voltage from VCC will bypass to the reset terminal, and it is sorted to the ground through the register R2. So this one, okay, and this pin is internally connected to the reset terminal of the flip-flop. When this signal goes low for a moment, the flip-flop receives the reset signal and resets the flip-flop. Hence, the output will become low again and stays there until the trigger is applied. The waveform of the bistable mode of operation of the 555 IC timer is shown here. This is trigger input when S1 is pressed. See, this is trigger input when S2 is pressed for the reset. This is for set, and this is bistable output. Okay, so that's actually the operations here. Now, okay, once again, this is the circuit diagram. No C is used, capacitor, that is not required. Okay, so initially this is pressed to supply is sorted to the ground for the set, and the output will be low, and unless until it is pressed and it is reset, and the output will again come to the another stable state low. So in this way, so this is work. Now we'll this is the waveforms. Now we'll discuss its applications of 555 timer flip-flop as flip-flop and as a memory cell circuit. So it is not a great choice to use 555 timer as a flip-flop in computer applications. In typical computer application, the clock pulse is used to drive the trigger and reset signals, and the frequency of the clock signal is very high. Generally it is in the order of gigahertz, and the output of the 555 timer is not responsive enough to match the speed of the clock signal's frequency, and readily available flip-flop devices are preferable when used in the high speed operations. That's why the 555 timer is in bistable mode, that is as a flip-flop, can be used in low speed non-computer application like robotics. A simple application is a robot which moves forward and backward every time it hits an object. That being said, the circuit of a flip-flop using 555 timer is shown below as a flip. Here it is, the circuit. So a little bit modification is there. When this pin output pin 3 is high, capacitor C charges through this register R1 to the peak value of VCC. When the output at pin 3 is low, the capacitor discharges to the register to 0. Okay. In order to switch the output from high to low or low to high, a switch is used at the junction of the trigger and the threshold. This is the junction, this is trigger and this is threshold here. So threshold pins. The voltage divider formed by this R2 and R3 will provide a voltage VCC by 2 at the pin 6 and 2. When the switch is pressed, the voltage is interrupted and triggers the internal flip-flops. This will allow the output to switch between the two states, the low and high. Circuit detects as a toggle flip-flop is shown here. It is used to light an LED, and the LED switches between on and off, and the switch is pressed when the switch is pressed. So this is like this. Okay, everything is the same. Only difference is here. This is the output. Okay, in the output level. So it is connected in the output. Here, this is the output. Okay. So that is actually, that's why this is the use of a bistable as a flip-flop. Then memory cell. Memory is an important unit in digital electronics, and flip-flops are the basic 1-bit storage elements. 555 timer, when used as a flip-flop, can act as a memory cell to store 1-bit data. The circuit of a memory cell using a 555 timer is given here. It's act as an SR flip-flop. See, this is the circuit. Okay, and the connection is similar to the bistable mode of operation with a few extra components. See, similarly, more or less same with some extra components here. Okay, so actually when this set switch is placed, this one, the voltage at pin 2 goes low, and this will set the flip-flop and the output becomes high. Okay, which drives the LED connected to it here. When the reset pin is placed, this S2 at pin 4 goes low, this will reset the flip-flop and the output becomes low, turns off the LED. Okay, so in this way actually this bistable multivibrator circuit used as a memory cell. It can store up to 1-bit data of memory used in the digital electronics use. So with this we are about to complete our discussions of the switching and timer circuits. We have firstly discussed the switching and timer circuit, and then we have discussed its application, different stable, monostable, bistable multivibrator circuit using op-amp. And after that we have discussed about the basic of IC 555 timers and its use as a stable, monostable and bistable multivibrator circuits. And in every case we have discussed about their applications. In case of using 555 timer circuits for multivibrator 555 timers used in multivibrator circuits, and we have discussed like op-amps used in multivibrator circuits, 555 timers also used in the multivibrator circuits, and we have discussed their basics, circuit diagram, their operations, their waveforms, and at the same time we have discussed their applications in stable mode, in monostable mode, in bistable mode. And I think you have enjoyed this switching and timer circuit module, and I told you that this is very important for our study in power electronics and drives, circuits for detail about the converters of inverters